All right. Okay, so let's just backtrack where we were last week and just read this and go over it again, fill in everything we know. All right, so in the diagram, ABCD is a parallelogram. So we knew that the opposite sides were parallel and equal. Let me use 3 because there's 2 there. All right. Parallel diagonals bisect each other. All right. So that equals that. All right. So in other words, if this is P and this is Q, then this is P plus Q. All right. And that equals that, but that piece equals that piece. So therefore, that equals that. And that was the first part. Prove that AT equals SC. All right. Why? Because the diagonals bisect each other. So AP equals CP, but part of them are equal, so the rest is equal. Okay. And then we had to prove that triangle PSR was similar to PBA, this one. All right. We know that these two are vertically opposite. We know that that equals that because of angles in the same segment, right? Remember, it was like the bow tie or the butterfly. And so the angles are all the same in both. It has 2 equal angles, so therefore the third will also be the same. And therefore they were similar. And then from there we could write out the similarity. And that's, we wrote that out and then we didn't carry on. Okay, so remember what I said. Even though they're not asking you for any ratio here, you write it anyway. Why? Because the question continues. You might use that information here. And I'm pretty sure that you do. Okay. All right. So it will be PS over PB equals SR over BA equals PR over PA. All right. So that follows from similarity. And you just keep it there because you're thinking, well, maybe I need it later. All right, so if it is further given that PR over PA equals TR over AD. So they're giving you this, you've got to work with that, right? Where else can you see a PR over PA? There we go. So if they're telling you that that is that, it can be included in this whole thing, right? Equals TR over AD. That's the part that they've given you here, which means that equals that and that equals that. So that might help. They want you to prove that triangle RPT. RPT. This small one is similar to APD, the big one. So the small one and the big one. We want to prove that those two are similar. Now, what sides are we using here for RPT and APD? We're using RP. There's an RP. We're using, so it's RP, AP. There we go. PT and PD. No. And RT and AD. Okay. They should automatically be the same then. APD, but that's obvious then. Because if this ratio is the same, then we're working in triangle RPT and APD. There we go. It's the same letters. Right. So it wasn't too bad, this one. Although I think that you could also have probably used this information as well. PR over PA equals PS over B. So let's look at these two. All right, that we got from the first lot. Would that help? Yeah, so those three are the, so if we looked at the three of those, PS, PR, TR, PS, PR, and TR. PS is the same as that, right? So instead of PS, we could actually write PT over PB equals that. Right, they gave you that, but now you also know that. So it's PT over PB. And isn't PB the same as PD? See how it unfolds. So there's your APD then. PT over BD, PT over PD, PR over PA, PR over PA, and TR over AD. There we go. So the two triangles are similar. All right. Okay, and then you have to prove that ATRD is a cyclic quad. ATRD, you want to prove that this is cyclic. So you need to think of the theorems to do with cyclic quads. So opposite angles are supplementary, exterior angle equals opposite interior, things like that. Okay, but seeing as we have just proved that these two triangles are similar, angle P will equal angle P, there it is. Angle PSR equals angle PBA. PSR. Oh, sorry, I'm looking at the wrong one. Angle R equals angle A. Angle R PT. R PT, that angle equals APD, which is the same, right? Then PTR, this angle equals PTR, second, third, first, second, third, first, PDA. So PDA, so that one equals that one, and then the remaining one equals the remaining one. All right, so, right. And doesn't the exterior angle of a cyclic quad equal the opposite interior? There's your cyclic quad. If you extend that length, the exterior equals the opposite interior. There they are equal to each other. So therefore, that must be a cyclic quad. It cannot be a cyclic quad if these two are not equal to each other. Okay, there we go. So all you need to state is that angle T1 equals angle D2. It follows directly from the similarity. Reason, similarity, and there we go. Exterior angle equals opposite interior angle. Therefore, that is a cyclic quad. Right. It can be tricky, hey? Not easy. These are quite tough. Right, any questions? Nothing at all? All right. Okay, cool. So that was the end of that one. I think I had another paper here, so let's look at it. All right. Let's see if I can move this up. Perfect. Okay, I'm going to wiggle this as much as I can so that I can see all the questions. Right, perfect. In the diagram, PQRS is a cyclic quad. They didn't need to tell you that. You can see that the 4 points, the 4 vertices are on the circumference of a circle. So what do you know about a cyclic quad? We know that the opposites are supplementary. So 180 minus 108 will be there. Okay. What else do we know about a cyclic quad? We know that the exterior equals the opposite interior. Right? We don't know what these are yet, so let's look at this information. They're telling you that this is a tangent, so you're thinking of tan chord theorem. That angle equals that angle, right? And this angle, well, we don't have, there's no line there, right? Right, so what did we say? We said this is equal to that. We don't know what that is. So then this is x plus 42. Exterior equals opposite interior. And we know that this is x as well because that's isosceles. They told you those are equal. So we can surely work out x. All right, x plus 72 equals 180. Angles in a triangle. So 2x is equal to 108. And then divide by 2. So x is 54. And 54 plus 42 is 96. Right. Are there any other angles we can find? We can find that one, angles in a triangle. 108 plus 42 is 150, so this is 30. Just check my algebra, please. Right, so angle Q, 72, reason, opposite angles of a cyclic quad are supplementary. Angle R2, isosceles triangle. Angle P2, tan chord theorem. Angle R3, exterior equals opposite interior. All right. So make sure you use all the information. Cyclic quad is implying things. Tangent is implying things. Equal lines is implying something. All right. Everything they tell you, they're telling you for a reason, usually. Right. Everyone happy with that? No questions? Right. All right. Let's have a look at this one. Question 9. In the diagram, PQRS is the cyclic quad. Is a quad, so not cyclic. PQRS. It has diagonals. W is a point on PS. WT is parallel to PQ. All right, so as soon as you see that, do you notice the big triangle and the small triangle? Okay, so small, big. So there's definitely proportion happening here. Small over big equals small over big equals small over big, for example. All right? Or that over that equals that over that. So just bear that in mind. TV is drawn, PW to WS. PW to WS is 3 to 2. Okay, so the ratio is 3 to 2. It doesn't mean it is 3 and it is 2. The ratio is 3 to 2. And they want the value of ST to TQ. ST to TQ. Ah, so there's another triangle with parallels. You see those two parallels? So same situation. Big, small. Okay, small triangle, big triangle. All right, so if they want ST to TQ, ST to TQ, small to piece equals small to piece. So that will be 2 to 3. All right, so be very clear that you can see that scenario happening. Then SV over VR. that over that is the same as that over that. So it's also 2 to 3. Small over piece equals small over piece in this scenario. I just want to see if this carries on. Prove that angle T1 equals Q1. T1 equals Q1. Okay, so you want to prove that that is equal to that. All right. Okay. The only way that those two can be equal is if these two lines are parallel, then they'll be corresponding. So if you can show that these two are parallel, so if you look at this triangle, that line and that line, if they were parallel, it would mean that that to that would equal that to that. And what was SV to VR? It was 2 to 3. And what is ST to TQ? It was also 2 to 3. So yes, these two are parallel. And therefore you have corresponding angles. So that equals that. Okay. What was the next question? They said complete the following statement. Triangle VWS is similar to some other triangle. Okay, VWS. VWS. Okay, so this triangle is similar to what other triangle? All right, so you can see that this triangle is the small and that is the big. So it's similar to that one. So just remember to name it in the correct order. Okay, if it's SWV, then it's SPR. And if it's the other way around, those are swapped. Okay, so it's SPR or SRP. VWS. Oh, VWS is the same as RPS. Right, I want to write it here somewhere. Triangle VWS is similar to triangle always have to move this up and down, sorry. VWS is the same as RPS. Right, RPS. And then, of course, remember, you can write out the proportion. So VW over RP equals WS over PS equals VS over RS. Right, I don't know what they asked here. So unfortunately, I have to flip back again. They wanted WV over PR, which is that. And they're saying you must find the ratio of that. Okay. WV to PR, yeah, so it's that. So in order to find that, it would be nice if we had those, right? So what about VS to RS, for example? VS to RS. In other words, small to big. It's the same as small to big. Small to big. VS over RS. Small to big equals small to big. So 2 to 5. Right. Okay, so it's important that once you have written out your proportion, written out your triangles in the correct order, that you then write out your proportion. And whatever they're asking you to find, obviously needs to be lurking there somewhere, somehow. Right, are there any questions? Nothing. Everyone's 100% okay. Right, I know that these are quite tricky. Right, okay. I'm not going to start another one, okay? I'll rather leave one for next time because we're going to get halfway through it again and it's just such a pain. So we'll carry on with that next time. Yes, it's 5 because it's the whole line, small to big. So 2 plus 3. Small to big, 2 plus 3. Correct. All right, super. I'm going to go, and great. I'll see you on Monday. We'll carry on. We'll do some more similarity. I think it's quite important. And in the meantime, practice as much as you can. You know where to find the papers, and we'll just carry on. We'll just plod through them. Thanks, guys. Bye.